Exponents with integer and rational bases. We need to remember what exponents and powers are. So if I look at the first example, it says, how could you read? And in part A, it has 4 with a number up in the air. That's a 2. That's a power, and it's read as 4 squared, or 4 to the exponent 2. In part B, it's read 5 to the exponent 3, or 5 cubed. In C, it's still the same thing, even though the base is now a letter. It's read as x squared, or x to the exponent 2. And D is y cubed, or y to the exponent 3. So when we move further ahead, we need to know, what exactly does a power mean? If I have the power 36 to the exponent of 7, it means 36 multiplied by itself 7 times. That's referred to as the expanded form, and the number 36 is called the base, and the 7 is the exponent. Evaluate the following powers and think about what each power means. 4 squared, or 4 to the exponent 2, means 4 multiplied by 4, and that gives you an answer of 16. 5 cubed means 5 multiplied by itself 3 times, or 5 times 5 times 5, which is 125. Evaluating exponents on your calculator can be done rather simply, but it depends upon your calculator what button you choose to do it with. So you need to be careful when doing this and make sure you've got your own calculator and you're comfortable with it. If you're using somebody else's all the time, you won't know what button to look for. So to evaluate 5 cubed on a calculator, you're going to look for one of 2 buttons. You're going to look for a button like this, which has a little, I call it a hat, or you're going to look for a button that has a y with an exponent of x. It may have an x with an exponent of y. You'll have to play around with your own calculator and try it out. So when you do 5, press the exponent button, one of the 2 buttons that I've circled in pink on the screen, then press 3 for the exponent and press your equal button. You should get the 125 we got on the page before. Pause the video and try and evaluate that now. Once you've done part A, evaluate part B with your calculator. So again, you're going to put the base in first, so 2, and then you're going to use either y to the x or the little hat button, and you're going to put the exponent of 5 in and hit equals, and you should end up with an answer of 32. Now what we see here is a little bit different. These are powers that have fractions as their base, or rational bases, because if in part B, we've got some positives and negatives. So 3 over 5 squared really means 3 over 5 times 3 over 5, which if we look at that, we're going to take our numerators and multiply them, and we're going to multiply our denominators. And 3 times 3 gives me 9, 5 times 5 is 25. Negative 2 over 3, all cubed, because the brackets are around the whole thing, the exponents on everything means negative 2 over 3 multiplied by negative 2 over 3 multiplied by negative 2 over 3. We're going to multiply all our numerators, we're going to multiply all our denominators. And a negative multiplied by a negative multiplied by a negative is going to give us a negative, and that's negative 8, and 3 times 3 times 3 is 27. Is there a faster way to evaluate powers with rational bases? Absolutely. I could just evaluate the numerators, because you can see, I'm going to change colors here for a minute. If I look here, I could just write that top number as negative 2 cubed. And the bottom number, because it's 3 times 3 times 3, I could have written as negative 3 cubed. That didn't work very nicely. So I could have written the numerator as a power and written the denominator as a power. So in general, absolutely, we can do it faster. We can raise the numerator to the exponent and the denominator. So just like what I showed you over there, 3 over 5 squared means 3 squared over 5 squared. Negative 2 over 3 cubed is negative 2 cubed over 3 cubed. And we can just evaluate those on our calculator that way. And that allows us to show our work as well. So when we're trying to show an understanding, we've shown it by doing that.